So, topic 6 test review, starting with number 1. It just wants the value of x. What some of us tried to do is we tried to set these two equal to each other. I cannot assume they are equal. Okay, the only way I could assume they're equal is if they told me that this shape was regular. Okay, it is not, so we have to find what all of these interior angles add up to. How do I find what all of them add up to? What's the formula? Yep. So we're going to use n minus 2 times 180. What does n stand for? Number of sides. So I'm just going to count how many sides there are. 1, 2, 3, 4, 5, 6, 7. Okay, so I plug in 7 for n. 7 minus 2 times 180. 7 minus 2. 5. Make sure you do that part first. 5 times 180. 900. Okay, so what that gave me is all of these angles on the inside add up to 900. Okay, so how can I set up an equation if I know all of these add up to 900? Add all of them up, set it equal to 900. Okay, what some of us are doing, which is fine since you don't want to write them all out, I get that. Okay, some of us are just seeing them from here, and we are combining like terms, which is fine, but am I forgetting some like terms? Don't forget that these ones with the x's are also like terms with the whole numbers. Okay, so if I combine all of those whole numbers, I get 477. And then how many x's are there? 3. So I have 477 plus 3x equals 900. If you didn't like that, you could write all of them out and then combine like terms that way. Okay, so how do I solve this? Subtract 477. So I get 3x equals 423. Last step. Divide by 3. X equals 141. That is all it wants you to do because it just wants to know the value of x. 2 through 5 is all about interior and exterior angles. So there are some formulas here and there are some things that you just need to know. So number 2, what is the measure of the sum of interior angles? Okay, wants to know the sum of interior angles. What's the formula for that one? N minus 2 times 180. How do I know what n is? Number of sides. How do I get that from here? Tells us that it's a dodecagon. How many sides is a dodecagon? 12. Okay, so I plug in 12. I get 12 minus 2 times 180. 12 minus 2. 10 times 180. 1,800. And it wanted the sum. Okay, so we just need to find the sum. Number 3 is a little different because it wants to know one interior angle. How do I find one interior angle? We're going to divide the sum that we get divided by the number of sides. So we find the sum using this formula, n minus 2 times 180. And then we divide that by the total number of sides. Okay. How do we find n? Right, decagon is how many sides? 10. So I'm going to plug 10 in for my formula. So we have 10 minus 2 times 180 divided by what? 10. 10 minus 2? 8 times 180? Does anyone remember? 1,440 divided by 10 is? 144. Biggest thing between 2 and 3 is making sure you know what you're trying to find. One wants the sum, one wants one of them. Okay. Number 4 says, what is the measure of the sum of exterior angles of a hexagon? Automatic. 360. Did I even need to know the number of sides? No. Okay. Exterior angles is automatic 360. Okay. Number 5, last one with these. It wants one exterior angle. How do I find one exterior angle?
360 divided by the number of sides.
Yep. Take 360 divided by the number of sides, which, how many sides does a pentagon have? 5. So 360 divided by 5 is 72. Good. Okay, moving on to number 6 and 7. Now we're getting into all the different shapes that we talked about. Okay. Number 6 says, what must this angle be for PQRS to be a parallelogram? First of all, are we talking about angles or sides right now? We're talking about an angle. So we want to look at what they gave us for the angles. What did they give us?
The opposite one.
They gave us angle Q and angle S. What's nice about angle Q and S? They equal each other. Remember, opposite angles in a parallelogram equal each other. Okay, so how can I find the value of x? Set them equal to each other. We have 6x plus 13 equals 7x minus 5. So we solve. 13 equals x minus 5. Last step. Add 5. What'd you get for x? X equals 18. How does that help us? We can plug it in, right? Does it matter which one of those I plug it into?
No.
Nope. Which one do we want? Q or S?
6x.
Okay, so we're going to plug it into Q here. So I have 6 times 18 plus 13, which gives us 108 plus 13, which is 121. What did that just give us? 121 is angle Q and angle S. Okay, opposite angles are the same. How does that help us find what we are looking for? Right, how do we know that? Right, and opposite angles are the same. What do we do if angles aren't the same? We subtract from 180. If angles are not the same, you're going to subtract it from 180. So 180 minus 112 is it? It's not 112. Thank you. It's 121. Sorry. $121. So subtract 180 from 121 to give us 59. Okay, so no, angles that aren't the same add up to what? 180. And opposite angles are equal. Okay. Any questions on number 6 before I erase the picture? Okay, I'm going to erase because we're going to use this on number 7. Number 7 says, if A equals 2, what is the value of B? So this question doesn't really tell us anything about the image other than that A equals 2. So we need to find where A and B are. Are A and B in regards to sides or angles? Sides. Okay, what do we know about sides of a parallelogram? Opposite sides are equal. Okay, doesn't matter which sides I choose. It does not. I'm just going to pick these two sides to work with. Okay, I know 6b is equal to 11b minus 10a. What can I do from here if I know a is 2? I'm going to plug it in, right? If I know a is 2, I'm going to plug that in for a. So this turns into 6b equals 11b minus 10 times 2. So we have 6b equals 11b minus 20. So now we just solve for b. We have negative 5b equals negative 20. Last step, divide by negative 5. What'd you get for b? B equals 4. Could I have used, looking at that picture up here, could I have used these two? Yes. Okay, you would get the same answer. Does not matter which sides you choose. Okay. Number 8. The diagonals of a parallelogram ABCD intersect at P. Select all the statements that must be true. It does not give us a picture, so what should we probably do? Draw one. Okay, we should all know what a parallelogram is by now. If you don't, here you go. Everyone draw a parallelogram if you have not yet. Okay, there's my parallelogram. The hardest part, or the most tricky part, is labeling. Making sure you label correctly. It tells us the vertices of ABCD. Do you think I can just do this? No. What should I do? Go in order, right? Does not matter if you go this way or this way, just as long as you stay in order. Okay, so I'm just going to go A, B, C, D. And then what are diagonals?
They were like cross.
They are the ones that go through the shape and cross each other. Yep, so here's my diagonals. They intersect at P. Okay, so there's my picture. Now we can go through all the options and select all that are true. So, is AP congruent to CP? Yes. I'm going to back up a little bit. We know opposite sides are the same. Opposite angles are the same. What do we know about diagonals? They aren't the same, but they bisect each other. That's why we can say these are congruent to each other. Okay. Next one is BC congruent to AD. True or false? True, because opposite sides are the same. True or false? This angle right here is 90 degrees. It is false. Yep. CAD. This angle is congruent to this angle. True or false? I heard some true, I heard some false. Let's talk about this. What word is in parallelogram? Parallel. So we know opposite sides are parallel to each other. What is this line that goes through the parallel lines? It's a diagonal, but it's also a transversal, okay? So those two angles right there, what's their relationship with each other? Alternate interior. What do we know about alternate interior angles? They are equal. Yep, alternate interior angles are equal, so that makes D true. Okay, and then last one here. Erase. BPC. So this one is congruent to APD. True or false? Why is that one true? Vertical angles. Yep, vertical angles are always congruent to each other. So biggest thing with this one, draw yourself a picture. I'm going to ask you this because you may see this on your test. Is AP congruent to DP? Yes or no? No. Okay, remember diagonals are not equal to each other. They just bisect each other. Okay, so two different diagonals do not have congruent parts. Okay, keep that in mind. All right, last one's on the front, 9 and 10. True or false? All sides of a rhombus are equal. That one is true. One of the properties of rhombus is that all sides are equal. Okay. And then number 10, diagonals and rectangles are angle bisectors. That one's false. Yep. What if I asked you, are all true or false? All sides of a rectangle are equal.
False.
False. Diagonals and squares are angle bisectors. True. True. Do we use the names of polygons? Yes. Number 11. So it says select all statements that are true about the square. What's nice is they actually give it to you this time. Okay, so going through, is FP congruent to 2EG? What does it mean by 2EG? 2 times, right? So is FP congruent to 2EG? True, false? That's false. Yep. Is EP equal to EH? False. Yep. Is EP congruent to GP? Yes, true. GP congruent to HP?
Yes.
True. And then does EFH equal 45?
Yes.
How do we know that for sure when it doesn't give us any angle measures?
Because the whole angle is 90 degrees. It's split in half.
Yep, whole angle's 90, and remember these diagonals in a square split that angle in half. So 90 divided by 2 gives us 45. Okay, what I want you to take a note on for studying tonight, okay, circle number 11. Number 11 is the same format, but instead of a square, it's a rhombus. Okay, it's the same format, but instead of comparing a square, it asks you to compare a rhombus. Okay, there's 3 things we know about a rhombus. Are you ready? One of them we just talked about. What do we know about all the sides? All sides are equal. Okay, that's one. Do we remember what the diagonals do? They bisect each other and they form a 90-degree angle. So they're perpendicular bisectors. And then there's one more. Something they do to the angles. Bisect the angles. Yep. So all sides are equal. They're perpendicular bisectors and they're angle bisectors. Okay. Did I say anything about the diagonals being equal to each other? No. Okay, so all sides are equal. This is for rhombus. All sides are equal. They are perpendicular bisectors, the diagonals, and the diagonals are angle bisectors. Okay, so keep that in mind for number 11. It's going to ask about a rhombus. Let's move on to number 12, everyone's favorite one. Crickets. Okay. This one is asking for AD. First of all, what shape is this? Trapezoid. We talked about the mid-segment formula. I want you to write this down. Mid-segment equals base 1 plus base 2 divided by 2. You are going to use this formula to help you out. Now, what you want to look for to find the value of x to help us is you want to find a trapezoid where I can plug in the mid-segment and both bases. Okay, do I have all three of those things? I do, right? So some of us are probably looking at this whole diagonal, or that whole trapezoid. But do we see this smaller one on the inside? Okay. How do I know which one's the mid-segment? The one that's in the middle. Okay, this one's our mid-segment. How do I know which one's base 1, which one's base 2? Doesn't matter. Okay, so here's my two bases. So do I have all three things in order to use this formula? Yes. So we're just going to plug it in. So mid-segment is what? 7x plus 2 equals, one of my bases is 8x minus 7 plus the other base, 10x minus 1, all divided by 2. So what this just made for us is a big algebra problem. So we just have to solve, what do we want to get rid of first? The fraction. So I'm going to multiply by 2 on both sides. One thing to be careful of, on the left side, you have to multiply both of these by 2. Okay, so 2 times 7 is 14x, yep, and then 2 times 2, 4. Do you agree these 2's cancel out? Okay, what can I do on the top here? Combine like terms. What's 8x plus 10x? 18x, negative 7 minus 1, negative 8. So now all I have to do is just solve. So I'm going to subtract 14x. 4 equals 4x minus 8. What do I do from here? Add 8. 12 equals 4x. Divide by 4. X equals 3. Now, what do you think we do since this isn't our answer? What are we going to do with it? We're going to plug it back in. We're going to use it. Okay? We're going to plug it back into all of them, and I'll explain why in a second. Okay? If I plug it into this top one, 8 times 3 minus 7, 17. 7 times 3 is 21 plus 2, 23. 10 times 3, 30 minus 1, 29. Now, again, we're looking for this length right here. You very well could use this formula again, but does anyone know a trick? Find a pattern. Yep. The reason we can assume the pattern is because all of these sides are the same. Okay. So how do I get from 17 to 23?
6.
Add 6. 23 to 29. Add 6. So what do I need to do to 29? Add 6. 29 plus 6 is 35. Good. So I think the biggest thing is going to be just setting up the problem. Okay. Once you find x, plug it back in, look for a pattern. What if it asked you for BC, this top one? I would subtract 6. I would go backwards. Yep. Number 13 through 15. I gave you information that this was 63, right? Okay, and this is K. What shape is this? It's one of the first ones we learned. It's a kite. Okay. Number 13 wants us to find this angle right here. What is that angle?
90.
Why can I assume that's 90? It's a perpendicular bisector. Yep, these diagonals create a 90-degree angle. Okay, so we can assume that one's 90. Next one, it wants us to find GHK, this one right here. How can I find that? Right, if I know two angles, remember we always look for triangles. If I know two angles, how do I find the third? Yep. 63 plus 90 is 153. What do I do with 153? Take 180 minus 153, which is 27. And then number 15 wants us to find this angle here. What's the trick for this one? It's the same as the other side. It's mirrored to each other. So this is 63. So this one right here is 63. The one opposite corresponding part to that is also 63. Number 16. Coming up here, it tells us it's a parallelogram, so we can assume all the things. On number 16, it wants us to find BAC, which is this angle here. Always use what they give you. See if it can give us more information. What's something we can do that'll help us? What can I do with these two angles right here? Why would I want to add those together? Right, and it'll give me the whole angle B, right? Okay, so I'm going to take 71 plus 45 to give me 116. So this whole angle B is 116. What is also 116? D, opposite angles are equal, so D is also 116. How does that help me find A? How can I find the whole angle A?
180 minus 116.
Right. Are A and B the same angle? Do they have the same angle measure? No, because they're not opposites. So if they don't have the same, what do they add up to? 180. So we're going to take 180 minus 116 to give us 64. So this whole thing right here equals 64. Now how can I find X? Right, if the whole thing's 64 and some of it's 27, to find the rest, I can just take 64 minus 27, which is 37. Okay. Number 17, it says if BE, I'm going to erase the picture. All right, if BE is 2x plus 2, and BD is 5x minus 3. It wants to know what is, and it tells us AE is 4x minus 6. It wants us to find X and AC. We need to find X first. I tried to outline it for you. How do we find X? What is something else we know about that picture? The other side is what? Yep, BE and ED are the same, so this side's also 2x plus 2. How can I set up an equation here? Correct. Some of us said I can just set these two equal to each other, which is true, but this is going to give, do you agree any value of X I plug into here is going to come out equal? Okay, so this is going to get us an infinite amount of answers. So we don't want to set it up this way, even though this is true. Okay, so what's a different way I can set it up? Yep, add these two together, set it equal to the whole thing. Okay, so I'm going to take 2x plus 2 plus 2x plus 2 equals 5x minus 3. What should I do on that left side? Combine like terms, so we get 4x plus 4 equals 5x minus 3. And then solve. 4 equals x minus 3. So what do we get for x? Yep, x equals 7. Okay, now, next order of business is it wants us to find AC, which AC is this whole thing here. How can we do that?
Plug it into AE and then times 2.
Yep. Do you agree AE is a part of AC? Yep, and we know it's half of it, right? So I can plug 7 into here. So I get 4 times 7, which is 28 minus 6, 22. So this here is 22. What do I know this is? Also 22. So if I want the whole thing, yep, multiply this by 2 or add 22 to get 44. Number 18. What shape is this? Trapezoid. It wants NPQ. This angle here, the whole thing. Again, try and use what all they give you. What can I do with these two angles here? Yep. I take 30 plus 32, which is 62. This whole angle right here is 62.
And then it's just opposite, so you can, it's also, wait, no.
So trapezoids are a little different.
Yeah.
Which angles are the same in trapezoids? Those sides are the same.
N and N.
Oh, I see what you're saying. N and P are the same. And then M and Q are the same. Remember, the ones connected to the same base are the same measure. So are M, the one we know, and P, are they the same?
No.
Is this angle the same as this angle?
No.
No. If they're not the same, how do we figure it out?
180 minus 62.
Yep.
They will add
180 minus 62 is 118. And then last one here. It tells us that MP is 5.9. MP here is 5.9. It wants us to find RN. I kind of covered it up, but it wants that side length right here. What do we know about diagonals of a trapezoid? They do equal each other. Yep, diagonals are equal. So what do we know about NQ?
It would equal
It equals 5.9. Yep.
5.9 minus 4.1.
Yep. Take the whole thing, which is 5.9, minus what you already know, 4.1, to give you 1.8. Okay. 1 to 5 on the backside. This bottom part. Also know the names of the polygons with side lengths of 3 and 12. Let's go over. And look at 1 through 4. If you ever wrote them down, we're going to write them down right now. Okay. 3. Triangle. I am not going to dock you for spelling. You just need to be close. Okay. 4.
Quadrilateral.
If you say square, am I going to count you wrong?
Yes.
Yes. Has to be quadrilateral. 5.
Pentagon.
Pentagon. 6.
Hexagon.
Hexagon. 7.
Septagon.
No.
Heptagon.
Heptagon. 8. Octagon. 9.
No.
10.
Decagon.
11.
Hendecagon.
Good job. Hendecagon. Last one, 12.
Dodecagon.
Dodecagon. Hey, if I randomly threw 13 at you. 13 gone. This here, listen before you pack up. This here should be an easy 10 points for you. This is 13% of your test. Okay, easy 10 points for you. Take 5 minutes to get to know those and you'll memorize them. Okay, why do you think I'm having you memorize these?
Because it's for class.
No.
We'll use it in the real world.
Well, and you'll,
We just showed.
okay, so you need to know these. They will pop up. Okay,